Hello everyone, this is Mr. Muhammed Azeez. Previously we stopped right here on question 21, and in this lesson we start from this question and let's solve it. Plants growth. A greenhouse can sell dwarf trees 6 years after they are planted. So 6 years after they are planted means when they sell the dwarf trees, t equal to 6. Full stop. The function h prime, this function is derivative. See the prime? H prime t equal to 1.5 t plus 5. Models dwarf trees rate of growth. This is also evidence that this given function is derivative because it's rate. Rate means derivative. And we have the height of one dwarf tree was 12 centimeters when it was planted, t equal to 0. This is a point. The height is 12 when it was planted. When it was planted, number of years is 0 and the height is 12 centimeters. We can use this point later to find the value of t. Now, let's write the question. The question is like this. 1.5 t h prime t equal to 1.5 t plus 5, and I know a point 0, 12. Let's find h. Find h of t, or find the equation of the height. This is h prime. To remove prime, we need to use integral. Integral 1.5 t plus 5 dt. Integral removes derivative. So integral of h prime t will be h of t. Integral removes prime. Now let's do the integral. 1.5 stays the same. Integral of t will be t squared over 2 plus 5 becomes 5t plus c. There is simplifying. 1.5 divided by 2. 1.5 divided 2 is 3 over 4. I can change this to 3 over 4, or I can just leave it like this. Now to find the value of c, replace t with 0, equalize the result to 12. 1.5, 0 squared over 2, 5 times 0, plus c equal to 12. These cancel out. This will be 0, this will be 0. Now I know the value of c is 12. c equal to 12. Now I write the function h of x, and instead of c I write 12. Finally, h of t equal to h of t, not x. There is no x for this question. It's just t. Equal to 1.5 t. I can write it as 3 over 4 t squared plus 5t. Instead of c I can write plus 12, or you can just keep it like this. 1.5 t squared over 2. This one is also correct. T squared over 2 plus 5t plus 12. This is the function h of t. Then in part b, after finding the function h of t, in part b it is asking for what will the height be when it is sold. When the plant is sold, t equal to 6, I found the function h of t. It's here. Just input 6 in place of t. 1.5 multiplied by 6 squared divided by 2 plus 5 times 6 plus 12. Then in the exam you don't have time to be too creative, just use calculator. 1.5 times 6 squared equal to 54, divide by 2, that is 27, plus 5 times 6 is 30, plus 12. All that sudden, oh, I wrote minus 12. Okay, it was 57 plus 12, that is 69. 69 centimeters. The height of the dwarf tree is 69 centimeters when it is sold. Part B is complete. This question originally does not have part C, but I wrote part C for it because it has been in Wizari like this. What will its height be 1 year before selling? 1 year before selling, they sell it when t equal to 6. 1 year before selling means t equal to 5. Now in this function, replace t with 5, you will get the result. That is how you can find it. Now we have some relation between s of t, v of t, and acceleration, which we had in chapter 3, section 4. We used to take derivative for s of t, which is the position function, to get velocity, and then take derivative of velocity to be acceleration. This time, since we studied integral or integration, we can just go back. I can take integral of acceleration and go back to velocity. Take integral of velocity, go back to the position function s of t. Let's look at this example. This one, a car that had stopped at a traffic light. The car had stopped at traffic light, started at an acceleration of 2 meters per second squared. At the same time, a truck overtook the car at a constant velocity. Look at the question. For the truck, velocity is given. For the car, acceleration is given. Velocity needs one integral to be s of t, and acceleration needs two integrals. We need to do the integral twice to get s of t. Then we equalize s of t of the truck, which is the position of the truck, to s of t of the car, to find after how many meters will the car be beside the truck. After how many meters is related to position. Meters is distance. Distance is related to position. Now I need to find s of t of the car, and I need to find s of t of the truck, then equalize the two s of t's to find the point where the truck and the car are beside each other. Let's do it. So we begin with working for the car. Acceleration of the car is 2, integral of 2 is 2t plus c. Since the car had been stopped, then c equal to 0. So v of t of the car is 2t. Now v of t, velocity, if we take integral of velocity, the result will be acceleration. Now if I take integral of 2t, which is going to be 2t squared over 2, that is the position function of the car. Same reason why c equal to 0, because the car was not moving, then c is equal to 0. 2 cancels 2, at the end s of t of the car is t squared. Let's write s of t of the car is t squared. And this t squared will be equalized to s of t of the truck. For the truck, velocity is given by taking one integral, we will get s of t. Velocity of the truck was 10. Integral of 10 is 10t. C is equal to 0 again. Now we equalize t squared equal to 10t. Send 10t to the other side. T squared minus 10t equal to 0. Take t as common factor. T minus 10 equal to 0. Now we are going to have two solutions. One of them t equal to 0, which is not counted. Why? Because when the time was 0, the car and the truck were beside each other. Then the truck overtook the car. So this t equal to 0 is not considered. Then the other one, t minus 10 equal to 0, t equal to 10. So the car and the truck will be beside each other after 10 seconds. But if we look back to the question says after how many meters. It does not say after how many seconds. Now I know the time where the truck and the car are actually beside each other. Put this time into s of t. Doesn't matter if we use s of t of the car or s of t of the truck. Now I know t equal to 10. So s of 10 equal to 10 squared. 10 squared equal to 100. That means the car and the truck will be beside each other after 100 meters. And what if someone uses s of t of the truck? S of t of the truck is S of 10 for the truck is going to be 10 times T is also 10, equal to 100. So the truck and the car are beside each other after 100 meters. All right. In part B, the question is asking for what will the velocity of the car be when it's overtook by the truck? To find the velocity of the car, we already have the equation of velocity of the car, which is right here, 2t. Just put 10 in place of t, because we know when the car and the truck were beside each other, the time is 10 seconds. Just put t in place of this, replace t with 10, put 10 in place of this t. 2 times 10 is 20. So the velocity of the car was 20 when it overtook the truck. Here we have some true-false questions that are very good questions. Every antiderivative of a polynomial function of degree n is a polynomial function of degree n plus 1. Well, by polynomial they mean basic functions, like a function that contains only x and numbers, no fraction, no exponential, no radical, no trigonometric. Something simple like x power 2 plus 3x minus 1. This is polynomial. If I do integral of this polynomial, which is power 2, the result will be another polynomial, which is power 3, and only the highest power matters. Every antiderivative of a polynomial function of degree n, when we do integral, we say power plus 1, so the result will be another polynomial, which is power n plus 1. That's true, and this is a rule by itself. 27. If f is a polynomial function, then it has a unique antiderivative whose graph passes through the origin. Well, this is true. Antiderivative means result of integral. Any function has one antiderivative or has a unique antiderivative through a certain point. Here the certain point that is mentioned is the origin. Then this is true. But if we look at question, there's a question down, look at question 30. It says every function has only one antiderivative. That's false. But if they mention a point, then it will be true. Like every function has only one antiderivative through a given point, any point. It will be true. The difference between question 27 and 30, 30 is false because no point is mentioned. 27 is true because a point is mentioned. Here origin is mentioned. Origin is a point. It is 0, 0. Now question 28. If two antiderivatives are equal, then the functions are equal. That's true as well. If we have two antiderivatives that are equal, then the difference between them is just a constant. If I take derivative of f, I'll get f prime. Take derivative of g, I'll get g prime. But look at here. If I take derivative, the side becomes f prime, the side becomes g prime, and the c, which is constant, becomes 0. Then these two will be equal. Question 29 is false. Integration cannot be distributed on multiplication. Integration could be distributed on addition, subtraction. It cannot be distributed on multiplication and division. And here we have a very good question. I can say this is the best question in this section. And similar questions to this have been in Wizari a lot. Almost every year there has been a question, same idea as this one in Wizari. I'm going to solve this one properly in the notebook. And you need to pay attention to it. The question looks short, looks simple, needs understanding. Now, View 100% is a lot, 80 is good. Let's begin. Firstly, f double prime is given. In order to get f back, I need to do integral twice. Another thing that is given is horizontal tangent at a point. Alright, horizontal tangent at a point is telling me slope equal to 0 when x is 2. And by slope, we mean f prime 2 equal to 0. F prime 2 is the slope of tangent at x equal to 2. And since the slope is horizontal, the tangent is horizontal, the slope is 0. I'm going to use this to find the value of c in the first derivative, which I get by taking integral of the second derivative. First derivative is equal to integral of the second derivative. Now let's practically find the integral of the second derivative. Now f prime x equal to integral 2x dx. Integral of 2x is 2x squared over 2 plus c. This is f prime x. Now I need to know something about f prime x to find the value of c. And luckily I do know, depending on the given that says horizontal tangent. Now f prime 2 equal to 0. This is f prime. If I replace x with 2, result will be equalized to 0. 2 power 2 plus c equal to 0. 2 power 2 is 4. 4 goes to the other side. C equal to negative 4. Now I can write f prime x properly. F prime x equal to x squared minus 4. I want to find f. To find f, I need to do integral of f prime. Alright, I do have f prime. Let's do integral. Fx equal to integral x squared minus 4 dx. Integral of x squared is x power 3 over 3 minus 4 becomes 4x, and there's always plus c. How can I find plus c this time? How can I find the value of c this time? Now, since I have a point given to 0, every point that is where the tangent occurs is right on the graph. So if I replace x with 2, the result will be 0. Y will be 0. This 0. This 0 is because of the horizontal tangent, not because of this 0. And this 0 is this one. Now in f, the one I just found, I'm going to replace x with 2 and equalize the result to 0. 2 power 3 over 3 minus 4 times 2 plus c equal to 0. Let's find c. 2 power 3 is 8. 8 over 3. 8 over 3 minus 8. 4 times 2 is 8. 8 over 3 minus 8 is negative 16 over 3. Now I have negative 16 over 3 plus c equal to 0. Negative 16 over 3 goes to the other side. C equal to positive 16 over 3. Now I can write fx with confidence. Fx equal to x power 3 over 3 minus 4x. Instead of plus c, I write plus 16 over 3. This is the answer. This is fx. Now we're going to move to another question, but let's zoom this out and let you see the whole answer in one go. There you go. Taking a picture. Yeah, that's it. Look at it. This is the answer. Going back to the book, no need to check the answer. Pause the video, try to use all of your knowledge to solve this question. So whenever you see these Q's, these are my own question. And it is easier than your expectation. Indeed, not that easy that you can do it by only looking. You need to sit and solve. The last question in section 1 is question 32. Question 32 is a piecewise function. Let's solve this one as well. Piecewise function, the graph will not be given, by the way. I drew the graph to help you understand, and if you don't think you can understand from the graph, just ignore the graph. Do it algebraically. Now I remove the graph. It's ready to go to the notebook. Nice and clean. Paste this all. Paste. Zoom. Zoom in. Cool. This is cool. F prime is piecewise. Okay. I don't know why students hate piecewise a lot. It's like a piece of cake, but it's a piecewise cake. I don't know how to say it. Anyways, f prime x is piecewise, so its integral will be piecewise as well. So integral cannot fix it. The function is piecewise, integral will be piecewise, derivative will be piecewise, graph will be pieces, domain will be pieces. Anyways, let's do this. This is f prime. The question says find f. Find f means take integral. Okay, what is integral of 1? As I said, fx will be piecewise as well. Integral of 1 is x plus c. Integral of 3x is 3x squared over 2 plus c. Conditions won't change. 0 less than equal to x less than 2. 2 less than equal to x less than equal to 5. Now, one thing is very important. The question says continuous. If you studied chapter 2 well enough, you know if a piecewise is continuous means when we input 2 here and there, the results will be equal. This is how we can see or we can tell a piecewise is continuous. And if a question by itself said this piecewise is continuous, that means the common number, which is 2, if I input 2 here and input 2 here, the results will be equal. And the result is given, which is 6. See how easily I can find c. Replace x with 2. 2 plus c equal to 6. 2 to the other side, c equal to 4. And for the other piece, I use the same point. Input 2 equalize to 6. 3, 2 squared over 2 plus c equal to 6. 2 squared 4 divided by 2 is 2. 2 times 3 is 6. 6 plus c equal to 6. The c seems to be useless because 6 is already 6, doesn't need anything to be added with. Or you can say send 6 to the other side. C equal to 6 minus 6, c equal to 0. So this c is just 0, goes away. And this c is 4. Now fx is x plus 4 and 3x squared over 2. We found fx. Is this function differentiable at x equal to 2? Let's check. Differentiable means if the derivative has left and right equal. The derivative is already given. No need to find derivative again. This is f. Derivative is already given. Put 2 here. Result will be 1. Put 2 here. Result will be 6. Since left is not equal to right on the derivative, the side is 1, the side is 6, means the derivative has problem at 2. And if a derivative has a problem, we don't say the derivative has problem. We just say the function is not differentiable. At where the problem happened, at 2. So f prime 2 is undefined, or f is not differentiable at x equal to 2. Because when I input 2 in the derivative, one side becomes 1, the other side becomes 6, while according to the definition of continuity, left and right must be equal. If in a derivative left and right are equal, the derivative is okay, exists, and the function is called differentiable. The function is differentiable at a certain value. But if a derivative has problem, left is not equal to right, then we say the function is not differentiable, not the derivative itself. The function could be differentiable or not differentiable. This is the end of section 1. Thank you so much for watching. Stay tuned to see the rest. No, wait. There are some questions I want to show you. I just remembered. The exponentials. Exponentials. Integral of e power x, like this is a rule. Integral of e power x is just e power x. Stays the same, the exact same thing. Now question 8. For exponential function, the derivative of power is very important to be available. Now, derivative of this x is just 1. 1 is always available outside. This 2 is constant. The 2 stays the same. Integral of ex is just ex plus c. Now look at here. The derivative of power is 2. Do we have 2 outside? Yes, we have. Then cancel the 2. E power 2x is directly the final answer. So if you follow this note, you can skip this step. Then what we do, let's repeat. Search for the derivative of the power. The derivative of this power is 2. Do I have 2 outside? Oh yeah. The derivative part gets cancelled. It will be sacrificed. Then the result will be e power 2x plus c. This is e power 2x plus c. Now look at this one. What is the derivative of the power is 5. Do I have 5 outside? No. I need to write 5 here. Times. It's not minus, it's times. And to keep the balance, I write 1 over 5 outside. Now again, look at the 5. I wrote it to cancel it. Derivative of the power is 5. 5 is available outside. 5 gets cancelled. This negative 4 is constant. It's multiplication. Stays. The 1 over 5 is outside the integral. Stays. So the negative 4 and the 1 over 5 both stay. And the part e stays the same. E is always doing that. Stays the same. And there is always plus c. Then I can multiply this negative 4 by this one. As you know, if we multiply a number by a fraction, we just multiply it with the numerator. This question, derivative of power is 1 over 2. I don't have 1 over 2 outside. Then I write 1. 1 over 2. To keep the balance of 1 over 2, I write 2 over 1 outside. Now, derivative of the power is 1 over 2. The 1 over 2 gets cancelled. E power x over 2 stays the same. This is e power x over 2. And the 2 over 1 outside stays. It's multiplication. 2 over 1 is just 2. So at the end, we get 2e power x over 2 plus c. Question 12. Again, we can skip this step. Why? Because the derivative of the power is negative 4. It is available outside. The negative 4 gets cancelled. E power negative 4 plus c is the answer. E power negative 4 is not in the simplest form. So we need to write 1 over e power 4x. Now the negative 4 became positive and the plus c stays right where it is. Yeah, this time, this is the end of the session. Thank you so much for watching. Soon you're going to see 5.2.